Well, here we go again. And we are in the middle of our Unit 6 discussion. Last time we talked about just general equations, right? We said, hey, an equation is a representation of a chemical reaction, and we talked about the symbols, the components, and we also talked about our diatomic molecules. Now, let us move on. Consider the reaction of solid sodium with water to form aqueous sodium hydroxide and hydrogen gas. Okay, that seems to be a piece of cake. Write the balanced, the balanced equation for this reaction. Okay, I think we need to learn some more stuff. Let's go with green. I'm going to need a new line. Let's go. Wow. Okay, a balanced equation. Balanced equations. Okay, so what are balanced equations? Well, this would be if I go with a definition over here, what's a balanced equation? I would say that this is an equation, a Kim equation, in which the number of each type of atom in the reactants equals the number of each type of atom in the products. I guess another way to say this is, and I don't like that green, that doesn't look very good. This would be a chemical equation in which, oh, it's a chemical equation which shows, let's put it this way, which shows conservation of mass. And what's conservation of mass? That simply means what? Mass is neither created nor destroyed. Mass is conserved. And so what we're saying is this is an equation which we're showing that mass is conserved in the reaction, and specifically, for instance, the number of hydrogen atoms in the reactant side equals the number of hydrogen atoms in the product side. The number of, if there are oxygen atoms in the reactant side equals the number of oxygen atoms in the product side, and so forth. That is a balanced equation. Good. So, how do we go about this? What's the process for writing a balanced chemical equation? The first thing we do is usually we usually are starting, not always, but usually we start with a word equation. And that's what we've been given so far. This is a word equation. Okay, good. So I have a word equation, and then what am I going to do once I have my word equation? Well, we want to identify my reactants, yoink, and products. Okay, we've been doing that so far. Let's go down here. A reaction of solid sodium with, that would be what, plus water to form. That would indicate I'm going to have a yield here. Aqueous sodium hydroxide and hydrogen gas. So what are my reactants? Well, solid sodium and water are going to be my reactants, and sodium hydroxide and hydrogen gas are going to be my products. Good. So I've identified my reactants and products. Yeeks. Now I want to write my formulae for reactants and products. Reactants and products. And we've done that so far. We did that in our last unit, in our last lecture. Sodium, how do I write sodium? In, it's solid. How do I write water? H2O. Although I'm going to start writing water this way, and you'll see why in just a little while. Liquid yields what? aqueous sodium hydroxide, NaOH, aqueous, plus hydrogen gas, H2. Good. All right. So we've done all that, and we're an expert at that really by now. What do we do next? 4. Balance atoms in reaction by adjusting only coefficients. And this is what? What are we really doing here? By employing conservation of mass. Conservation of mass. Okay. What do I mean balance atoms in reaction by adjusting only coefficients? Well, what are coefficients? Coefficients are the things that go in front. So a coefficient would be here, a coefficient would be here, a coefficient here, a coefficient here. If nothing is written in front of these, we're assuming that the coefficients are what? 1. Okay, so we can only adjust my coefficients. What that also implies is once I get my formulae written, I don't change my formulae. Right? I don't change H2O to make it balanced. The only way I can balance things is to put numbers in front of my items. Okay, how would I do this? Well, let's look at some tips. What are some tips maybe that will help us balance? Well, let's write down here. I've got balancing, and then off of balancing my equations, let's come down here and let's write down some tips. What are some tips? Okay, tips. Number 1, never change your formulae. That's number 1 tip. You don't do that. Number 2, try to start with something that is start with an element which is only in one compound on both sides. Start with element only in one compound on both sides. That doesn't always happen, but that's a place we can start. What else? What are some other tips? I like to often start with another place to start with. Start with most complex compound and put 1 in front of it. I guess another tip here is this is all trial and error. Trial and error. So use a pencil. Okay, and it's kind of difficult to talk about this, to list tips. It's really better just to see how this works. So let's go here and let's work on it. Here's the way I would approach this. I look at this and I say, okay, I've got 1 sodium on this side. I've got 1 sodium on this side. So those are balanced. So I have sodiums, right? I have 1 on this side, 1 on this side. Hydrogens. Okay, let's look at my hydrogens. I have 1, 2 on this side. So I have 2 hydrogens here. I have 1, 2, 3 on this side. So my hydrogens are not balanced. Okay, so what does that mean I have to do? Well, I have to do something. And now this is where it helps me if I look at water as HOH, because let's take this and look at it a different way. Let's look at my polyatomic as a separate thing. We'll call it an OH here. So I have 1 OH here and 1 OH here. Now I look at my hydrogens. I have 1 hydrogen here, and how many hydrogens do I have over here? I've got 2. So it looks like my hydrogens are not balanced. Now, do you see the subtlety of what I did? I said, consider the OH. the water as being made up of H plus and OH minus. Okay, cool. And that means I already have an OH minus over here. So, which leads to another tip. Let's write down another tip. When possible. 5. Consider polyatomics as single entities. Entities. What does that mean? Don't break them up. Do not break up unless you have to. Do not break up when you're trying to balance these things. Look at them as C and OH, not as an O and an H, but C and OH minus as an OH, as a hydroxide, a whole unit, not as one O and one H, like I did here. Okay, so back here. So when I look at this, I say, well, I got a problem here with my hydrogens. I have 2 hydrogens on the right and only 1 on the left. So what am I going to do? I need to get another hydrogen. How am I going to do this? Well, don't change the formula. So we have to do what? Put a new coefficient. So I'm going to put a coefficient of 2 in there. Well, that means everything's going to have to change here, right? My scorekeeping. So now let's put H and OH. I have 2 H's on my right side. I have 2 H's on my, 2 on my left, 2 on the right. Now, how many OH's do I have? Well, I have to take my coefficient and multiply that through. So I have 2 OH's on my left. I only have 1 OH on my right. So what must I do? Put a 2 in front of that. So now I have 2 OH's here. When I look at my sodiums, I have 2 sodiums on my right, and that means I need to put a 2 here, 2, 2, and now that is a balanced equation. Yikes! Which brings us to one other tip, right? One other tip is what did you notice that I did? Check. Make sure you check the number of atoms. Check number of atoms on each side and make sure that you have indeed a balanced equation. Here you go. You try this one. Are you ready? You brought me back? All right. Reaction of gaseous hydrogen. Okay. First thing I want to do is gaseous hydrogen and gaseous oxygen to form, that looks like my yield arrow, steam. All right. So ID my reactants. Hydrogen and oxygen are my reactants. Hydrogen and oxygen are my reactants. And I guess another tip, let's get it right now. Here's another tip. Holy cow, Mr. Smith, how many tips are you going to give me? I'm going to give you just, I don't know, 7 or 8. Remember your diatomics. Remember the diatomics, right? I brought clay from our new house. Remember, if I have oxygen or chlorine or iodine, that means it must be O2, I2, and so forth. So when it says here, hydrogen gas, it means it's got to be H2 gas. Oxygen, O2 gas to form steam. Steam is what? H2O gas. So I have my formulae. Now, remember, I don't want to change these once they are written. I can only change my coefficients. Well, let's start. I like to make my little table, H and O's. How many H's do I have on the left? I have 2. How many do I have on the right? I have 2. How many oxygens do I have on the left? I have 2. How many oxygens do I have on the right? I have 1. Okay, here's my problem. Don't have enough oxygens on the right. So what can I do? Can I change this coefficient? Can I change this subscript? No, I have to change the coefficient. Put a 2 there. All right, now what happens? Well, once I put a 2 there, 2 times 2, so how many atoms of hydrogen do I have? Well, I have 2 H2Os, which means I really have this, right? 2 H2Os. So how many total hydrogens do I have there? I have 4 total hydrogens, and I would have 2 total oxygens, right? Good. All right, hydrogens. Over here I have really what? An H2, and so that means I only have 2 here, so what do I need to do? I put a 2 in front of that. 2 means I really have that now, right? That's 2 H2s, and 2 H2s means I have how many hydrogens? 4. And how many oxygens? I have 1 O2, but if I have 1 O2, that means there are 2 oxygens there, so I have 2 oxygen atoms. That's my check, and this is my balanced equation. Yee-haw! Good. Moving on. Hey, we're almost done. All right. Consider the reaction of aqueous solutions of cadmium acetate, sodium chromate to form aqueous sodium acetate and solid cadmium chromate. All right. Pause me and bring me back when you're ready. Okay. So here we go. Aqueous solutions of cadmium acetate and sodium chromate to form. There's my yield arrow. So that would indicate these guys are reacting to form what? Sodium acetate and cadmium chromate. Okay, so on my reactant side, I have cadmium, CD, acetate, CH3COO. I'll need two of those. It's an aqueous solution plus sodium chromate, Na2CrO4 aqueous to yield, I've written too big, to yield, I should write smaller, but I write bigger, to form what? Sodium acetate, NaCH3COO aqueous, plus, I have to write real small now, cadmium chromate, CdCrO4, and what is it? Solid. There we go. Holy cow, look at this. Now, first of all, you have to write these formulae correctly, meaning you must know your polyatomic ions. Now I want to balance this, changing only what? My coefficients. Now, this is where, okay, so let's write down CD. This is where it makes sense. You know, I said keep your polyatomics, consider them as units, not as individuals, and not as individual atoms. So let's try to balance this. We're going to try to balance cadmium, acetate, chromate, and sodium. And where do you want to start? It really doesn't matter here. Let's start. This looks like the most complicated to me, so let's assume that there's a 1 here. So I'd have 1 cadmium on this side. How many cadmiums do I have on this side? I have 1 so far. Good. How many acetates do I have? Well, I have 2 acetates here, and what do I have over here? I have 1 acetate. That's not going to work. Okay, so let's start all over. What do I have to do? I have 2 acetates on my left side, so I have to do what? I need to put a 2. Yipes! Oh no! I just erased. I need to put what? Here's my sodium. I need another acetate here, so let's put a 2 here. Okay, so let's start all over. I have 1 cadmium. I have 1 cadmium. I have 2 acetates now. I have 2 acetates. How many sodiums do I have here? I have 2 sodiums, which means, hey, what do I have over here? 2 sodiums, and I have 1 chromate on this side, and I have 1 chromate on the, hey, that wasn't so hard. Yoink. This is our answer. Wow, just because it has a bunch of stuff doesn't mean it's hard. But I do like making this little table, and it is nice when you can erase. Here we go, the last one. You guys do this. Bring me back when you're ready. Aqueous solutions of chromium-3 nitrate. Chromium-3. Okay, I'm going to start way over here and write smaller. Chromium-3 nitrate. It's aqueous. Plus what? And potassium carbonate to form. Be careful, though, folks. So far, my reactants have always come first in the sentence. That doesn't have to be, because I can write it in a different way where my products are first. So read the thing carefully before you decide what's a reactant and a product. In this case, it says chromium-3 nitrate and potassium carbonate react to form. Okay, so those are my reactions. Potassium carbonate, it's aqueous, and it's going to form what? Aqueous potassium nitrate, KNO3, aqueous. Yikes, yikes. Plus solid chromium-3 carbonate. And like I say, you really need to know your polyatomics to get this stuff right. Because if you do not write your formulae correctly, you have no chance of getting the equation balanced properly. Okay, I'm going to make my little table, CR, keep my nitrates together, K2 or K, keep my carbonates together. Got it. All right, let's start over here. I have one. I'm just going to assume what? I'm going to assume that I start with a 1 here. If I start with a 1 there, I have 1 chromate and 3 nitrates on my left side. Over on my right side, I have 2 chromates already. Oops. Well, that's not going to work. So what do I have to do? Start all over. And instead of putting a 1 in front of that, I'm going to put a what? I'm going to put a 2 in front of this. Good. So now I have 2 chromiums. Did I say chromate? 2 chromiums. How many chromiums do I have over here? 2. How many nitrates do I have? Well, I have 2 of these things, right? NO3, 3. So I have 2 of these. And so how many chromiums do I have? That's easy to see. How many nitrates do I really have here? Well, I have 3 here and 3 here, so I have 6. So you'd take what? You'd take your coefficient and multiply it by the subscript. I have 6 nitrates here, and I have 1 written here, so what do I need to do? Let's put a 6 here. So now I have 6 nitrates here. How many potassiums do I have on the left? It looks like I have 2, and over here I have 6. So what does that mean? Well, that means my coefficient over here on the left can't be right. If I have 2 already and I need to get 6, I need to get 6, what do I do? Put a 3 in front of that. So now I have 6 potassiums, 3 times, I have 3 carbonates. How many carbonates over here? 3. Oh no, the bell rang. I guess that means you all have to go. Egads, don't leave the room until you make sure you have this correct. And that is beautifully correct. Happy Mr. Smith, a little hair on the side, give him eyes. Yay! I will see you next time.